Welcome to IT Career Institute. So we have already uploaded 2 videos on WBJEE 2022 chemistry solution paper, and I hope you have watched those previous 2 videos, and I hope you have understood all the solutions that I have mentioned there. So if you have any problem or any queries, feel free to mention it in the comment section below. So let's start with our third video, and we'll move on to our next 10 questions. Okay, so the 21st question is, how much solid oxalic acid, the molecular weight is given, has to be weighed to prepare 100 ml exactly 0.1 normal oxalic acid solution in water. So we know how to calculate the normality, right? So normality is basically equals to equivalent weight, just a second, weight taken by equivalent weight into 1000 by the volume, which is actually given in ml. So this is basically the formula for calculating normality. Now first let us find out the equivalent weight of oxalic acid given in the question. Equivalent weight of oxalic acid, that equals to, the molecular weight is given. So what is the formula? Molecular weight divided by the valency or the number of protons that the acid can liberate. So this acid can liberate basically 2 protons. There are 2 ionizable protons. Hence molecular weight should be divided by 2. Now the molecular weight is already given, that is 126 by 2. That will come around as 63 gram. So the equivalent weight we have find out. Now there is nothing to do. We just have to put the values in its respective places. So normality, normality is basically given. So let's put the value of normality there, 0.1. That equals to weight taken. How much weight is taken? That we have to calculate. So weight taken, let's write it weight taken only. And in the denominator, equivalent weight 63 gram. That into 1000 divided by volume. Now what is the volume given? 100 ml. So 2 zeros will cancel out, and let's put this weight taken on the left hand side. That will come out as 0.1 into 63 divided by 10. This, if I move this decimal place, will be 100. So the answer will come out as 0.63 gram, and which is our option C. So C is the correct option. So in the next question we are asked the major product of the following reaction is. So we have to predict the product of this given reaction. So basically this is an electrophilic addition reaction. So how does this reaction proceeds? So this is the alkene part. Here it's actually electron rich species, and it will be attracting the electron deficient species. So what is the electron deficient species? So if we dissociate HBr into the medium, then H plus and Br minus will basically generate, and this H negative pi bond will actually attract this H plus. Now there is a probability that this H plus may come and join with this carbon atom or with this carbon atom. So let us check out both the possibilities and see which one will be stable, more stable. So CH, if I consider that the hydrogen will get attached to this carbon atom, then this CH2 will become vacant, and the carbon atom will be like the plus charge will be on this carbon atom. Plus there is this next possibility where CH3 CH plus, where the plus charge is on the second carbon atom, and let me write this plus here, CH2, the other hydrogen is basically coming on this carbon atom. So which one is more stable? See here there are 3 fluorine atoms, 3 electronegative fluorine atoms. Now this carbon is already electron deficient. Now if presence of these 3 fluorine atoms, there will be a strong electronegative pool. Due to a strong electronegative pool, hence this carbon will become even more electron deficient, hence making it very unstable. So as compared to this compound, this has no such, see, the CF3 is quite far away from the carbocation center. So here the electronegative pull or the electron withdrawing effect will not be as we have observed in the previous case. So this will be quite more stable as compared to this. So basically the more stable carbocation is this one, and this won't basically generate. So now the Br minus will come and attack is at this electron deficient carbon center, and what we will get is CF3 CH2 Br. So this is our basically the answer, and here it matches with option A. So option A is the correct option. Okay, so the next question is the correct order of relative stability of the given conformers of N-butane. So here 3 conformers 1, 2 and 3 of N-butane in like Newman projection is given. So we have to predict which is more stable. Okay, so see here in 1 the 2 methyl groups are closely situated, right? So since the methyl groups are bulky or bigger in size, so the torsional strain between these closely spaced methyl group will be greater. Here in 2, the methyl groups are far apart from each other, so the torsional strain between the methyl groups will be none or minimum. And in 3, here also the 2 bulky methyl groups are closely spaced, so the torsional strain between them will be quite high. So between 3 and 1 there won't be much difference. Rather the stability of 1 and 3 are equivalent, and 2 will have maximum stability. This conformer is basically called the anti-conformer. So anti-conformer of N-butane is more stable always. So basically 2 will have greater stability, and then 1 and 3 has rather equal stability. So 2 will be more stable than 1 and 3. Now which is the correct option? That is our option A. So option A is the correct answer. So our 24th question is, benzene burns in oxygen according to the above equation. The equation given to us, and it's completely balanced. What is the volume of oxygen at STP needed for complete combustion of 39 gram of liquid benzene? So, see, 1 mole or 1 molecule of C6H6 is actually reacting with 15/2 molecules of oxygen, right? So, what is the molecular weight? First, we will find out in terms of molecular weight. What is the molecular weight of benzene? C6H6, that is for carbon atomic weight is 12 into 6 plus 1 atomic weight of hydrogen into 6. So that is 72 plus 6, that come out as 78. And the molecular weight of O2 is 32. So we can write 78 gram of benzene C6H6 is reacting with 15/2 into, what is the molecular weight? Oxygen 32, this many grams of oxygen. Therefore, what is for how much gram we have to calculate? 39 grams. So therefore 39 gram of C6H6 will be reacting with 15/2 into 32, this divided by 78, that is into 1/78, that is into 39. So this is coming out as 216, this is 239, 78 will cancel out, 2 will come here, 2 then cancelling out 16 and 8 will come here, so 15 into 8, that is coming out as 120 gram. Now the answer of that is how much oxygen is required to react with 39 gram, we have to answer it in terms of volume, and our answer has come in terms of weight. So we have to convert this weight into volume. So let me wrap this upper portion. So 32 gram, that is 32 gram is the oxygen molecular weight at molar weight of oxygen O2. So 32 gram of oxygen basically has 22.4 liter of volume at STP, right, at STP. So therefore 120 gram that we have calculated in our last step will correspond to how much volume? 22.4 divided by 32 into 120. This will come out as, if I calculate it entirely, it will come out as 84 liters, which is our option C. So C is the correct option. Okay, so the next question, 25th question is, Avogadro's law is valid for. All gases, ideal gas, van der Waals gas, trivial gas. So which will be the correct option? So this is a very straightforward question. If we have studied the Avogadro's law properly, the statement and the entire theory, then we know that Avogadro's law is valid only for ideal gas. So the next question, 26, is a metal M forms two oxides. The ratio M:O by weight in the two oxides are 25:4 and 25:6. Therefore, the minimum value of atomic mass of M is, so we have to calculate the atomic mass of this unknown metal. Okay, so let us consider the formula of these two unknown metal complexes be M2OX and M2OY. Why? Because the valency of metal is not known to us, but this much is clear that the valency of the metal is variable. That is, it is capable of exhibiting two valencies. Otherwise, two different ratios won't have been possible, right? So we have considered one valency to be X and the other valency of M to be Y. And the valency of oxygen is 2. So in both the cases, we have put 2. Okay. Now, if I consider the atomic mass of M, capital M, that is the metal, to be small m, say I have considered it. So how many metals are here present? 2 metals. So 2m divided by how many oxygen? X. And what is the atomic weight of oxygen? That is 16. So 16x, that is equals to the ratio. So this is the ratio of M:O. So the ratio is given, the first ratio is 25/4. So if I bring X on one side, so if I rearrange, if I cross multiply, then what will 16x will come up here, right? And 2m into 4 by 25 into 16. So this will come out as 4. This 2 will cancel out and this will come out as m/50. X is coming out as m/50. Let it be equation 1. Next, for M2Y, so let me write M2Y in this side so it will be more clearer. M2OY. So for here, the atomic mass of M has been considered to be small m only. So that remains here as well. So how many metals? 2. So 2 small into M divided by 16Y. That is the second ratio, 25/6. Now here Y will come out as 2m into 6 by 25 into 16. This is going to come out as 2834, that is 3m by 100. This is coming out as 3m by 100. Okay. So if I consider, now we have to find out the value of x and y by, so this will be the equation 2, by putting different values and then seeing if it is coming out. If I consider m to be 50, then x is coming out as 1, whereas y is coming out as, if I consider it to be 50, it is coming out as 50 here, 50 by 100 2, so it will be coming out as 1.5, which is not possible because valency cannot be fractional. Next, if m equals to 100, if I consider m to be 100, then x will come out as 2 and y will come out as 3. Now here positive integer are coming, so the minimum atomic mass should be 100. So the correct option is B. The next question, 27, is the de Broglie wavelength lambda for electron, proton and Ag2 plus ion are in the following order. Speed of EP and alpha are the same. So we have been provided with the condition that the speed of EP and alpha are same. So what is the de Broglie equation? That is lambda wavelength is equals to h by p, where h is the Planck's constant, p is the momentum. This can further be written as, p can be further written as mass into velocity. Now the velocity and the speed are the same thing, so the velocity is the same. So we have to compare with the mass. Now lambda, from this equation, what we are getting is lambda is directly proportional to 1 by m. So if mass is increasing, wavelength will decrease. Now we have, if we know the different mass of this electron, proton and Ag2. Now we know Ag2 plus, that is alpha, this is the mass, order of mass. that helium-2 has greater mass than a proton, which has greater mass than an electron. So the mass of helium-2 is maximum, so the lambda of He2 will be minimum. So alpha will have minimum wavelength, then will come proton, and then will come electron. So what is the correct order? That is option A. The next question is 1 ml of water has 25 drops. Let N0 be the Avogadro's number. What is the number of molecules present in 1 drop of water? Density of water is given as 1 gram per ml. Okay, so this sum is based on very basic concepts. So there is nothing difficult here. 1 ml correspond to, or 1 ml consists of 25 drops. So if I write it like this, simple unitary method, if I write it like this, 25 drops is equivalent to 1 ml, then 1 drop contains what is the volume of 1 drop rather? So it is equivalent to 1 by 25 into 1. So that will come out as 1 by 25 ml. Next we have to convert it into gram. 1 gram ml is the density. So rho of water is given, that is density of water is given as 1 gram per ml. Okay, now we know rho equals to mass by volume. So volume will be equals to mass, that is we will be calculating the mass. So mass equals to rho into volume. So rho is what? 1 gram per ml. That into volume is what? 1 by 25. Just now calculated. So ml will cancel out. We will be left with 1 by 25 gram. So next, let me rub this space. Let's come up here where we have calculated the mass to be 1 by 25 gram. Now we know that the molecular weight of water is 18 gram. Right. So if 18 gram, now we know that the molar volume contains how many molecules? Avogadro's number of molecules. Now 18 gram of water basically contains how many molecules? Avogadro's number of molecules. Now therefore 1 by 25 gram of water will contain how many N0 divided by 18 into 1 by 25. Okay, now this is basically our answer. Now we have to match it with the options given to us. See option B, here 18 is in the numerator part. So in no way it matches with our option, with our answer, right? So option B is not matching with our answer. So option B is discarded. Next, see 25 is in the numerator part. This is also not matching with our answer. So C is also discarded. Now we are left with A and D. So if I simplify this A option, see 0.02 by 9 N0. So if I remove this decimal part in the denominator, there will be 100. So 2 divided by 150. So N0 by 9 into 50. This option after simplifying coming out as this. And this option after simplifying is coming out as 0.04 by 25 into N0. If I remove this decimal, then into 100 at bottom. So 4 divided by 100 is 25. So N0 by 25 into 25 is coming. So this option is also not matching because in the denominator part there is 18 into 25 and not 25 into 25. So option D is also wrong. But see here the simplified version of option A is 9 into 50. If I split this 50 further into 2 into 25, if I write it like this, 9 into 2 into 25 and then I multiply 9 into 2, then it is matching with our answer, see. So 18 into 25, this is basically our correct option, so the correct option is option A. So the next question is, in Bohr model of atom, radius of hydrogen atom in ground state is R1 and radius of He plus ion in the ground state is R2. So we have to say which of the following is correct, which of the following option is correct. So from Bohr model, we know a relation where R, radius of an atom, is directly proportional to n, which is the principal quantum number, divided by z. Z is the atomic number, right? So we can write R equals to N1 by Z1 into Z2 by N2, right? Where 1 represents the first atom that we will be dealing with, that is hydrogen, and 2 denotes the second atom that we will be dealing with, that is helium. So in 1, so let me write it here. 1 actually is hydrogen and 2 is basically our helium. Okay, so what is the, see, in both the cases, both are in the ground state, both are in their respective ground state. So in ground state, what is the principal quantum number? 1. So N1 will be 1 and also N2 will also be 1. Now what is Z1? Atomic number of hydrogen is 1, and what is the atomic number of Z2? That is what is He, atomic number of He, that is 2. So R is coming out as 2. So this will be R1 by R2. So R1 by R2 is coming out as 2 by 1. Now here the options are given R by R2, 4, R1 by R2, 1 by 2, R2 by R1, 1 by 4, and R2 by R1, 1 by 2. So basically the reciprocal of our answer is given in option D. So this is the correct option. Question 30. Which one of the following is the correct set of 4 quantum numbers N, L, M, S? What is N? Principal quantum number, L azimuthal quantum number, M magnetic quantum number, S is the spin quantum number. Okay. So how do we calculate? For N, L is calculated as N minus 1 and N is calculated as 0 plus minus L, and S is plus minus half. So basically, see here, what are the principal quantum numbers that we have to deal with? Basically 4 options are given. Out of these 4 options, which is the correct option, we have to find it out. For 3, if N is equals to 3, then L will be equals to 2, right? N minus 1, that is 2, and M will be equals to 0 plus minus L. So plus minus 1 comma plus minus 2, right? And S will be always plus minus half. So let us check it out. 3 for N3. For L it is given 0. So obviously option A is the wrong option because L value should come out as 2. Okay. Next let us check out option B where N is given as 4. So L should be 3. M should be 0 plus minus 1 plus minus 2 and plus minus 3. And S should always be plus minus half. So for let us check out option B. So for B, for N equals to 4, L is 3, and if it is 3, then M should be out of like all these values, all these possible values are possible. So minus 2 is there, minus half is there. So it is almost coming as correct. So let us check out option C and D as well. N equals to 3 for option C. L should come out as 2, but here L is given as 1, so wrong. Option D, N equals to 4 is given, so L should come out as 3, but here it is given as 2. So the correct option is our option 3.